Picture this, June 2025. Mingyu Li, a doctoral student in Beijing, was doing routine work, sifting through telescope data, searching for radio sources in a patch of sky astronomers called the cosmos field. Then he saw it. Staring back from the depths of space was a face. Two bright eyes, a distinctive beak. The universe had created a perfect cosmic owl. What if I told you that right now, 8.8 billion light-years away, two ancient galaxies are locked in a cosmic dance that created something so extraordinary, astronomers had to look twice to believe their eyes. This isn't science fiction. This is the story of the cosmic owl, a discovery that proves the universe has an artistic side we never imagined possible. Now here's where it gets impossible. Ring galaxies, these cosmic donuts with bright centers and luminous rings, make up only 0.1% of all galaxies. That's 1 in 10,000. Finding two of them colliding, that's like winning the cosmic lottery twice in the same day. Yet there it was, clear as starlight. To truly understand this cosmic spectacle, we need to journey back in time. The light we're seeing today left these galaxies when the universe was only 5 billion years old. That's less than half its current age. We're literally watching ancient history unfold before our telescopes. Dramatic, the collision began 38 million years ago. In cosmic terms, that's yesterday. While dinosaurs still roamed Earth, these two galaxies started their gravitational tango, and they'll keep dancing for hundreds of millions of years more. We're just catching one frame of an epic cosmic movie. Lai wasn't working alone. His team included 14 researchers from China, the United States, Japan, France, Australia, and Denmark. When extraordinary discoveries happen in space, they bring our whole world together. On June 11th, 2025, they published their findings. 8 days later, another team confirmed it. Now let's talk about those piercing owl eyes. They're not just pretty features, they're some of the most violent objects in the universe. Each eye is an active galactic nucleus, powered by a supermassive black hole actively devouring matter from its surroundings. The left eye contains a monster, a black hole weighing 67 million times more than our sun. The right eye, a mere 26 million solar masses. As matter spirals into these cosmic beasts, it heats up to millions of degrees, creating lighthouses visible across billions of light-years. Each galaxy spans 26,000 light-years, about a quarter the size of our Milky Way. Together, they contain 320 billion times the mass of our sun. These aren't just big numbers. They represent structures so massive, our minds struggle to comprehend their true scale. When galaxies collide, they don't crash like cars. Individual stars rarely hit each other because space is mostly empty. Instead, gravitational forces create shock waves that ripple through gas and dust, compressing it into dense knots where baby stars ignite. Revealing, here's where it gets even more incredible. The left eye's black hole is launching a relativistic jet, a beam of charged particles moving at nearly light speed. This jet is slamming into the collision zone, further compressing the gas and supercharging star formation. But the owl's beak tells an equally remarkable story. This isn't just a cosmic coincidence, it's a stellar nursery working overtime. The collision between these galaxies has compressed enormous clouds of gas and dust, triggering an explosion of new star formation. Marveling what makes this even more extraordinary is the perfect symmetry. Both galaxies are nearly identical in size and structure. The collision angle was precisely right to create matching rings. From our vantage point on Earth, we see the cosmic owl face on, in all its glory. Remember that statistic, only 0.0% of galaxies are ring galaxies. The cosmic owl represents something even rarer, two ring galaxies colliding. It's like finding two four-leaf clovers growing from the same stem in a field the size of the universe. Educational ring galaxies form like ripples in a cosmic pond. When galaxies collide head-on, gravitational waves spread outward through the gas and stars. These waves push material into ring-like structures, creating the distinctive appearance that makes ring galaxies so rare and beautiful. This discovery was only possible because of the James Webb Space Telescope, humanity's most powerful eye on the cosmos. Webb's 6.5-meter mirror and infrared vision can peer through cosmic dust that would blind other telescopes, revealing secrets hidden for billions of years. In a universe with over 100 billion galaxies, finding this cosmic owl required perfect timing, perfect positioning, and perfect technology. It's a humbling reminder that the universe is full of wonders waiting to be discovered by those patient enough to look. Operating at temperatures colder than liquid nitrogen, Webb detects infrared light, essentially heat radiation from warm dust and gas. This allows it to see star formation hidden from optical telescopes, revealing the Owl's Beak stellar nursery in unprecedented detail. The Webb didn't work alone. The team used ALMA, the world's most powerful radio telescope, to detect cold gas in the collision zone. They used the Very Large Array to track that relativistic jet. Appreciative, modern astronomy is a symphony of instruments working in harmony. Human interest behind every cosmic discovery are human stories. Mingyu Li spent countless hours analyzing data, never knowing that one ordinary Tuesday would reveal something extraordinary. His team's excitement echoes through their published paper. The Cosmic Owl is an exceptional natural laboratory. Scientific Lid's team nailed it. This is a cosmic laboratory. Where else can you study galaxy collision, ring formation, dual black hole activity, and jet-triggered star formation all in one system? It's like finding a physics textbook written in the stars themselves. The collision has triggered a star formation rate 20 to 40% higher than normal. In the Owl's Beak, massive hydrogen clouds are collapsing under their own gravity. Nuclear fusion ignites, and new suns are born at an extraordinary pace, a cosmic baby boom. Humans are pattern recognition machines. We see faces in clouds, figures in constellations, and now owls in colliding galaxies. This tendency, called pareidolia, actually helps us connect with the cosmos on an emotional level, making the vast universe feel less alien. The cosmic owl's colors tell its story. The bright yellow-white eyes reveal super-hot gas swirling around active black holes. The blue beak shows the light of hot young stars just millions of years old. The surrounding rings glow with the warmth of stellar nurseries. This collision began 38 million years ago and will continue for hundreds of millions more. The owl face we see today is just one frame in an epic movie. By the time the collision completes, humanity might not even exist to witness the finale. When two galaxies approach, their gravitational fields interact long before any physical contact. These tidal forces begin reshaping both galaxies. It's like a cosmic dance where the partners begin influencing each other's movements from across the ballroom of space. But the cosmic owl is more than just a pretty face. Its symmetry reflects real physical processes, gravitational dynamics playing out on a galactic scale. The owl-like appearance actually helps us understand the underlying physics of these rare collisions. The cosmic owl's face won't last forever. As the collision continues, the rings will evolve, star formation will shift. Inevitable. Eventually, these two galaxies will merge into a single, larger galaxy. The owl will transform into something entirely new. The two supermassive black holes at the owl's eyes are destined to merge as well. When they do, they'll create ripples in space-time itself, gravitational waves that future detectors might capture, adding another chapter to this cosmic story. This discovery provides a window into the adolescent universe. At redshift Z144, we're seeing galaxies when the universe was young. Galaxy formation was at its peak, collisions were more common, and the cosmos was a more violent, creative place. Paradoxical. Here's a cosmic paradox. Ring galaxies are incredibly rare, yet they're crucial for understanding galaxy evolution. Sometimes the rarest phenomena reveal the most fundamental truths about how our universe works. Nature's exceptions often prove the rules. Systems thinking. The owl demonstrates cosmic feedback loops beautifully. Star formation creates heavy elements. Black hole jets regulate star formation. Galaxy collisions trigger both processes. Everything in the universe is connected in ways we're only beginning to understand. The cosmic owl helps us understand how galaxies evolved from small, irregular structures in the early universe to the diverse population we see today. Collisions and mergers are the universe's way of building bigger, more complex galaxies over cosmic time. Impactful. The cosmic owl discovery has already inspired new research directions worldwide. Teams are now searching for similar systems. We're entering a new era of galaxy collision studies, all because one student noticed an owl staring back from deep space. Computer simulations will help astronomers understand the precise conditions that created this perfect symmetry. What collision angle, what galaxy masses, what exact timing led to this cosmic masterpiece? The models are already running. Future-oriented, astronomers are planning detailed follow-up studies. They want to map the molecular gas, track star formation evolution, and understand exactly how that jet triggers stellar birth. The cosmic owl will be teaching us new physics for years to come. The cosmic owl fits into the larger story of cosmic structure formation. It shows how the universe evolved from smooth simplicity after the Big Bang. Through gravity and electromagnetism, it created the complex beauty we see today. Finding an object this rare helps astronomers understand the true frequency of galaxy collisions. It's like finding a rare species. One discovery can reshape our understanding of an entire population. The cosmic owl is rewriting textbooks. Celebrating, the Webb telescope has revolutionized our ability to find rare cosmic phenomena. Its sensitivity reveals details invisible to previous generations of telescopes. We're living in a golden age of astronomical discovery, and the cosmic owl is just the beginning. There's something profound about finding familiar shapes in the cosmos. The cosmic owl reminds us that we're part of the same universe. Connecting the same physics that shapes our world creates spectacular phenomena across billions of light years. The discovery required astronomical luck. Literally, the right galaxies, the right collision angle, the right time, the right telescope, and the right person looking at the right data at the right moment. Sometimes the universe rewards persistence. In an age of scientific explanation, the cosmic owl proves that understanding doesn't diminish wonder, it enhances it. Knowing how it formed through precise physics makes it even more remarkable than if it were just random chance. Public engagement. The cosmic owl has captured public imagination in ways technical discoveries rarely do. Its familiar face makes the vast universe approachable. Suddenly, everyone can see themselves in the cosmos, and the cosmos looking back at them. Celebrating serendipity. Lei's team wasn't even looking for ring galaxies. They were conducting a routine survey when the universe decided to show them something extraordinary. The greatest discoveries often come when we're looking for something else entirely. The discovery represents international collaboration at its finest. Researchers from 6 countries, multiple telescopes, different expertise areas, unified. When we work together, we can unlock the universe's deepest secrets. The cosmic owl brought the world together. Educational. This discovery is already being used in classrooms worldwide. Teachers use it to explain galaxy evolution, black holes, star formation. The cosmic owl is the perfect educational tool, complex science wrapped in an unforgettable image. Inspirational. Somewhere right now, a student is seeing this image and deciding to dedicate their life to understanding the cosmos. The cosmic owl isn't just teaching us about galaxies, it's inspiring the next generation of astronomers to look deeper. The discovery reminds us why we need dark skies and space telescopes. Light pollution prevents us from seeing these wonders from Earth. Protecting our view of the universe means protecting our ability to make discoveries like the cosmic owl. Time-focused. The cosmic owl is a time capsule preserving information about galaxy formation from the early universe. It's a fossil of cosmic evolution, frozen in time by the finite speed of light, waiting billions of years for us to discover it. Powerful. The energies involved in this collision are beyond human comprehension. The kinetic energy alone equals the output of billions of stars, yet from our distant vantage point, it looks peaceful, even beautiful. Distance transforms violence into art. The precision required to detect this object is staggering. Webb's mirrors are aligned to within nanometers. Its instruments can detect temperature differences smaller than a fraction of a degree across billions of light years. Human ingenuity at its finest. Team-focused. The cosmic owl discovery exemplifies modern astronomy's collaborative spirit. No single person or institution could have made this discovery alone. It took a global village to find this cosmic owl, and that's exactly how science should work. The discovery required processing terabytes of data. Modern astronomy is as much about data science as physics. Behind every beautiful cosmic image are thousands of hours of careful analysis, coding, and mathematical modeling. Future implications. This discovery will influence astronomy for years to come. It provides a new benchmark for understanding galaxy collisions. Future textbooks will have a chapter on the cosmic owl, marking it as a turning point in our understanding.